quiet. So let's see if we can make them sing. Y'all hear that?
Yeah.
This is a little bit more shy.
Yeah, that one was working okay today, but you know, as the day gets on, it gets a little shyer. This one's warming up though. All right, so what do you think's going on here?
You're putting something on them.
Yeah, all right, we are putting something on them. What we have is we have rosin, which you put on violins. So you know how like, whenever you have a violin bow and you draw the bow across the string, you hear like it makes noise. That's the same principle we're doing here. They're moving their fingers along the rod, and that's causing the rod to vibrate. And so when the rod vibrates, it vibrates so fast that it vibrates the air all around you. And then what happens is that it moves as a wave. It goes to your eardrum and vibrates your eardrum, and then you hear that. And so what you have here, they're vibrating so fast that the smaller one, it actually vibrates around 2,490 times a second. That's how fast these vibrate. So I know what you're thinking, like, but what does that sound actually look like? Do you think we can see sound? No? What if we set it on fire? Yeah, now we can see it. So what we have here is we call this our Ruben's tube. We have a propane tank, and we have little holes drilled all along it. And so what we do is, you see, we can light it. And then on this end, we have a speaker. And so just like the singing rods, how they vibrate, we can actually set a single tone into this, like a tone or frequency, which is just one note, like A sharp or B flat. We can send one note through this, and then you can actually see the waves of sound moving through the fire. So let's see if we can get this happening. Yeah? Let's see if Blake can get this going. Do we have power? All right. There we go. All right, so you hear that we have that one note coming through, and what we're going to do is we're going to see if we can get really well defined bumps in it. Okay, so you almost see if we can get it. There we go. So what we have here, we have 6 well-defined bumps. So for this Ruben's tube, we have what's called resonance, exactly, sorry. It's been a good day, a long day. Okay, so we have what's called a resonance. And so what a resonance means is that an exact number of wavelengths or waves can fit in that area. So it's an exact number, it doesn't change. What we can do is we can find another resonance point by either going up or down. We probably need to go down. And so you had 6, and now we're going, how many is that? 5. And notice they got longer. So as you go down in frequency, your wavelength actually gets longer. So if you go up in frequency, what does your wavelength do? Alright, it gets smaller, it gets shorter. Now, one frequency, one tone, that's cool, but what if we put multiple into our tube? What do you think that would look like? So you can see all these different rises and peaks as you have different notes overlapping each other. So waves actually overlap, and so whenever 2 high parts of a wave overlap, you get a really high spot. But then whenever 2 low parts come, you have a really low spot. And that's called interference. So you have this interference of waves, which causes the fire to dance. And that's really awesome. All right. So then next up in our show, we have